Hi guys, in today's video we're going to look at titrations, the use of an indicator, the range of our indicator. We're going to look at titration curves of a strong acid and a strong base, a strong acid and a weak base, a weak acid and a strong base, and finally a weak acid with a weak base. And then we'll look at an exam style question.
So, titrations. Well, I'm sure you will have come across titrations before. Titrations can be used to determine the exact volume of one solution that reacts with another. And titrations we're going to look at today are acid-base titrations. Now, there's an important feature of our titration that we need to know about, and this is called the equivalence point. This is the point at which the volume of one solution reacts exactly with the volume of the second solution. So in terms of our acid-base reactions, it's the point where neutralization takes place. It's the point where all of the acid has reacted with the alkali. So we'll have a look at where the equivalence point lies just in a minute, but first we're going to have a look at the use of an indicator because that can help us to determine when the equivalence point has occurred. So the indicators we use are often weak acids and they can be represented by HIN. And they form this equilibrium with the conjugate base and this proton it releases. Now, our indicators often take a different colour when in its acid form and in its conjugate base form, and that's what makes them so useful. So when the concentration of the acid form is equal to the concentration of the conjugate base, the indicator is at what we call its endpoint. So most of our indicators will change colour over a range of about 2 pH units. They go from the initial colour in its acid form to its endpoint form or vice versa. So it's important when we're using an indicator, we choose one where the endpoint is about equal to our equivalence point. Our indicator changing colour when our equivalence point is occurring is especially important because that allows us to identify when this equivalence point is occurring, and that's essential to our titration curves. So how do we choose an indicator that has the correct endpoint? Well, we look at what we call is the indicator range. So I said that most indicators change colour over a range of about 2 pH. For phenolphthalein, one of our indicators, it changes colour between about 8.2 and 10. So what you'll find is in more alkaline solutions, phenolphthalein will take a pink colour and acidic it will be colourless. With methyl orange, it changes colour between pH 3.2 and 4.4. In alkaline solutions, it's yellow, whereas in acidic, it tends to be more red. So having an understanding of how indicators work and their range is incredibly important. Before you go into your exam, I think it's a good idea to have a look through your data booklet, have a look at which indicators are given to you and familiarise yourself with their colours, their ranges and their endpoints, because it will be good for when you go into the exam to already have an idea of the tools that you can use in your questions. So we're going to have a look at something called our titration curve. So the graph we're looking at here is what we call a titration curve. In this instant, we're looking at titrations between a strong acid and a strong base. We're going to have a look at a number of titration curves, and each have their own unique and special features, which are unique to them. So you can see on the x-axis, we have the volume of base added in centimetres cubed, and we have the pH on the y-axis.
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific A-level chemistry videos, click the button. Join me today and together let's make A-level chemistry a walk in the park.